day learners! Welcome back to my channel. For today's lesson, I will be discussing the Module 5 of Quarter 3, which is about atom. Our learning objective for this lesson: determine the number of protons, electrons, and neutrons in a particular atom. But before we proceed on our lesson, let us know first these following reminders. Utilize the use of comment section to answer or ask questions, and use appropriate words when chatting in the comment section. In our previous lesson, we already discussed about matter. And matter is defined as anything that occupies space and has mass. We have two classifications of matter. The first one is pure substance. Pure substance is a form of matter that cannot be separated into two different particles or elements by any physical means. Meaning, it cannot be separated using mechanical process. The other one is mixture. Mixture was already discussed in your previous grade level. So we will now focus on the pure substance, specifically the atoms. So mixture is a combination of two or more substances that can be separated using physical or mechanical means. Pure substance are divided into two, namely element. Element consists of only one type of atom. Example, the elements in the periodic table. Each type element consists of a single type of atom. The other one is compound. Compound consists of two or more types of atom. Example would be molecule. Another example is sodium chloride, commonly known as salt. It consists of an element of sodium and an element of chlorine. So in this topic, we were going to discuss or focus on the differences of atom and molecule, as well as on how we are going to determine the number of protons, electrons, and neutrons in each atom or element. So let us define first what is an atom. Atom is a building blocks of matter, meaning this is the smallest indivisible particle of matter. All examples of matter consist of an atom. Either it is categorized as solid, liquid, or even a gas. While molecules, on the other hand, contains of two or more atoms that join together. It can be broken down into individual atoms. Example, the molecules of water. Another one, we have ozone. Ozone or molecules of ozone is a combination of two atoms of oxygen and a single atom of oxygen. As we continue the lesson, let us go back in time where the atoms was discovered. The first one is Leucippus. Leucippus was a pre-Socratic philosopher who developed the theory of atomism. Atomism is a natural philosophy proposing that the physical world is composed of fundamental components, which is known as atom. The second one is Democritus. He was a student of Leucippus and a Greek philosopher that discovered the atom. He called it as indestructible particles. There's a lot of philosophers, scientists, and experts who studied about atom, but Robert Boyle and Joseph Louis Prost supported atomism. The writings of some philosophers who supported atomism survived a lot of time during Middle Ages. Their work reached 17th century scholars who were then able to perform experiments that were related to atomism. And one of them is John Dalton. Dalton formulated the atomic theory. According to him, matter consists of tiny particles called atoms. Atoms are indestructible. A chemical reaction involves a rearrangement of atoms. No atom is created nor destroyed. The one particular element are all identical in mass and other properties. The atoms of different element differ in mass and other properties. When atoms of different elements combine into compounds, the constituents of atoms are always present in the same fixed numerical ratio. As I've said a while ago, there's a lot of scientists who studied about atom. And one of them is Joseph John Thomson. Joseph John Thomson discovered the electron using his experiment called as a cathode ray experiment. The other one is Ernest Rutherford that discovered the proton and neutron accidentally using his gold foil experiment. In 1921, neutron was theorized and searched by American chemist William Hawkins and discovered by James Chadwick. Since atom was discovered by different scientists, different models of an atom was also formulated. The first one is Dalton's model. Plum pudding model that discovered by Joseph John Thomson. Rutherford's model by Ernest Rutherford. Bohr planetary model that discovered by Niels Bohr. And Sommerfeld model that discovered by Arnold Sommerfeld. So atom came from the Greek word atomos, meaning indivisible or uncuttable. It has three subatomic particles, namely the proton, which is the positively charged particle, electron, the negatively charged particle, and neutron is neutral charge or zero in charge. The sample of an atom showing the three subatomic particles are shown in your screen. So we have here the proton, electron, and lastly, the neutron. As you observe, proton and neutron are located inside the atom, while electrons are circling on its orbit outside the nucleus. So here is the table showing the subatomic particles, describing its charge, the mass in terms of grams, and its location in an atom. Electrons has a charge of negative, has a mass of 9.109 times 10 raised to negative 28, and its location is outside the nucleus. The next one is proton, which is a positive in charge and has a mass of 1.672 times 10 raised to negative 24. And its location is inside the nucleus. And lastly, neutrons. Neutrons has a zero charge and has a mass of 1.675 times 10 raised to negative 24, and in terms of location is the same with protons. It is located inside the nucleus. So what are the parts of the element? So for us to determine its part, we use a representation. So the X1 is the atomic symbol of the element. It represents the symbol of the element. The letter A on the upper left right corner is the mass number, or also known as atomic mass. Mass number is the number of neutron plus number of protons. And lastly, the atomic number. The letter C symbol is the atomic number. Atomic number represents as the number of protons and electrons. So how are we going to determine the number of electrons, protons, and neutrons in an atom? So for us to get the number of electrons, we must know the atomic number. Atomic number, as I've said a while ago, that it represents as the number of electrons and protons. To get the number of neutrons, you have to subtract the atomic mass to atomic number. Example, the element of fluorine has a mass number of 19 and atomic mass of 9. So, the number of protons is 9. The number of electron is 9, while the number of neutron is 10. Why is it 10? Mass number minus atomic number, 19 minus 9, that is equivalent to 10. So that is the value of your neutrons. Another example is vanadium has an atomic number of 23 and atomic mass of 50.942. Okay, so in this case, for you to be able to get the number of neutron, you have to round it off the atomic mass into whole number. Okay, so the atomic number is 23, while the atomic mass is 50.942, or if you're going to round it off this value, it will become 51. Okay, so what would be the number of electrons, protons, and neutrons? So the number of electrons and protons is the same, which is 23. While the mass number, so from 51 minus 23, the value or the number of electron is 28. So let us check. Okay, so number of protons is 23. Number of electrons is 23. And lastly, the number of neutron is 28. So that's how you are going to get the number of protons, electrons, and neutrons. This is what periodic table of elements look like. So each of the boxes of elements here containing different values or numbers, such as the atomic mass, atomic number, and so on. Just like the picture shown in your screen. What about if you have this situation? You have the same element with same atomic number but different in atomic mass. What do you call this one? Atoms of the same element but different in number of neutrons or atomic mass is called isotopes. As you observe in the illustration, it has the same element, which is the element of carbon, which has the same atomic number, 6, but different in atomic mass. The first carbon has 12 and the other carbon is 13. So, since it has the same atomic number, meaning to say the number of protons and electrons of these two elements is the same, which is 6. What about the number of neutrons? The first carbon has the atomic mass of 13. Subtract it into 6. The number of neutron is 7, while the other one is 6. So this type of situation or elements called as isotopes. And let's try this. Get the number of electron, protons, and neutrons of the following elements. Number 1, zinc. Number 2, krypton. And number 3, barium. So that's all our lesson for today. Thank you. I hope you learned something. If you like this video or if you want more videos, don't forget to like, share, subscribe, and turn on the bell for our next science vlog class. Bye!